In this video, we'll be introducing addition vocabulary and talking about properties of addition. When we add two numbers, we call the answer the sum. The two numbers that we added together we refer to as terms, or sometimes we might refer to them as add-ins or summons. The properties of addition just tell us what we're allowed to do when we add two numbers. From a teacher perspective, this is important when we start to try to understand student errors. Consider the following. When I add 23 and 16, and I start with the ones place, it doesn't matter if I think about this as 3 plus 6 or 6 plus 3. Either way, I'll get the answer 9, adding in the ones place. The same with the 1 and 2. The order doesn't matter. Order does matter in subtraction. We can't switch the order and take 6 minus 3 to get 3 in the ones place. So knowing what we're allowed to do and why is important as we're addressing student mistakes. Let's start with the identity property of addition. The identity property simply says that if we add 0 to a number, or add a number to 0, we get that original number back. So if we had the number 5, we could add 0 or take 0 plus 5 and get 5 as our answer. This almost feels a little silly to list as a property, but if you stop and think about it, while this is true for addition, it's not true for subtraction. 0 minus 5 does not equal 5. It's not true for multiplication. 0 times 5 does not equal 5, and it's not true for division. 0 divided by 5 does not equal 5. Our next property is the commutative property of addition. This says it doesn't matter what order I add my numbers, I'll get the same answer. So I think about this as commuting back and forth to work. Commuting is moving around, moving a position. So if we move the position of a number, then we'll still get the same answer when we add them together, the same sum. So let's look at a specific example. Next, let's look at the commutative property of addition. The commutative property says that if we take two numbers, a and b, and add them together, we can change the order in which we add them and get the same result, the same sum. This one you can see the root, commute, like commuting to work, moving back and forth to work. Here we can move our numbers around and we still have the same sum. Let's consider the number 1. And let's consider the number 2, which will represent just with some dots, with some objects here. In this case, if we take 1 plus 2 versus 2 plus 1, we'll get the same result. And by result, I mean the total number of dots here will be 3, regardless of which order we added them in. This is really amazing when you think about learning your addition facts. So here, you don't have to learn the entire table of facts, because if you know, for example, that 3 plus 2 is 5, so 3 plus 2 is 5, then you also know that 2 plus 3 is 5. So you can learn half of the table and automatically know the other half. Next, let's talk about the associative property of addition. Here, if we add three numbers together, we can talk about their grouping. While the commutative property was moving numbers around, in the associative property we're not moving numbers around, we're grouping them or associating them differently. So we could group the A and B together, or we could group the B and C together, and we'd get the same results. Let's look at this with some numbers. If I add 1, 2, and 3, and I group the 1 and 2 together versus grouping the 2 and 3 together, I get the same result. We'll represent this with objects. Here, adding 3 plus 3 will give us the same result as adding 1 plus 5. How we associated or grouped the numbers didn't change the sum in the end. The associative property of addition comes in handy with situations like this. Some numbers pair together nicely to make our calculations easier. Here, rather than add 46 plus 98, I would much rather add 44 plus 100. I think of these as compatible numbers. They form a friendly number here, and I can see quickly that I have 144 as my answer, rather than having to do more work to add 98 and 46. The final thing we'll talk about is this statement. Whole numbers are closed under addition. This is our closure property of addition. Closed just means that if I add two whole numbers, I'll get a whole number. So whole numbers, remember, are 0, 1, 2, 3, and so on. It's our counting numbers plus 0. So if I add any two whole numbers, I'll get a whole number. That's not true of any addition. So this is not true of odd numbers. In other words, if I add two odd numbers, I don't get an odd number. So odd numbers are not closed under addition because adding two odd numbers doesn't give you an odd number. Whole numbers are closed. Adding two whole numbers will give you a whole number.